Now I request Dr. Srirang Bhatt, Professor and HOD of Mechanical Engineering Department, SJAC, and the chairperson of this program to welcome the dignitaries to the program.
Thank you, sir. Dear all, good morning. It's indeed my proud privilege to welcome the distinguished personalities and august delegates for this particular program. At the very outset, I would like to welcome our esteemed resource person of this session, Mr. Kumanan, NIT Trichy, for this particular program. Welcome to you, sir.
Yes.
It gives me immense pleasure to welcome our visionary leader, think tank of our college, our esteemed principal, Dr. Rio D'Souza, to this particular program. Welcome to you, sir. We are fortunate enough to be backed up by our senior most professor of the department, Dr. Raj K, who is also the convener of this particular program. Welcome to you, sir. More importantly, I would like to extend my red carpet welcome to all the participants who have joined across the country for this particular program. Welcome to all the proactive researchers and learners to this program. Welcome all. Also, I would like to welcome our supportive pillars of this particular program, Dr. Kenyut Sherwin and Mr. Noel Deepak Shiri, for their support and participation and meticulous work in conducting this particular workshop. I would like to put it on the record, the support and encouragement given by our management, our director, Reverend Father Wilfred Prakash D'Souza, and our assistant director, Reverend Father Alvin Richard D'Souza, for all the encouragement support towards all our research activities. Also, I would like to welcome all the deans, HODs of various departments for this particular program. Welcome one and all.
Thank you, sir. Now I request our beloved principal, Dr. Rio D'Souza, to share his thoughts on the 3-day faculty development program on recent advancements in materials and manufacturing, RAMM, and to address all the participants from across the nation.
Good morning to one and all. Our esteemed resource person of this morning's session, Professor Kumanan from NIT Trichy, also the HOD of Mechanical, Dr. Srirang Bhatt, conveners, Dr. Raju K and Mr. Noel Deepak Shiri, all the organizing committee, and my dear participants. Indeed, it's a great privilege to be addressing you this morning while you are preparing to deliberate on an important topic, the advanced materials and manufacturing. That is a very important issue which is coming up now. As you are aware, one of the things that engineers are supposed to do is optimize and make sure the resources that we are given are used to the best extent effectively, and the best outcome is there with the minimum use of resources. This optimization sometimes becomes critical when the resource itself is in short supply. And so it's always very important to work on the materials themselves that are used in the development of technology and development of new products. I think you are working on advanced materials, looking into many important features such as the cost of such materials, trying to reduce cost, increase durability, and now, like you can see on the screen, sustainability of such materials, whether they can be sustainably resourced and taken forward. So these are many important aspects that can be worked upon. I'm very happy the department has come up with this particular workshop, and a galaxy of very renowned people, persons from the country are going to deliberate, and I think the participants will be very much benefited by this particular interaction. I call upon all of you to take active part in all the deliberations and make sure that the workshop benefits all of you. So with this, I wish all the participants the very best. I congratulate the department and With this, I end my few words. Thank you. Thank you very much.
Thank you, sir. Now I request Dr. Raju K, Professor and the convener of this online FDP program, to introduce the chief guest speaker to the gathering.
A very good morning to one and all. Before I introduce the resource person to the participants, I would like to welcome and thank all the participants for accepting our invitation and attending this 3-day FDP program on recent advancements in materials and manufacturing. With this, now I proceed to introduce today's resource person, Dr. S. Kumanan. Dr. S. Kumanan is currently working as a senior professor in the Department of Production Engineering at NIT Trichy, Tamil Nadu. He basically obtained his BTech as well as MTech degrees from NIT Trichy. Later, he obtained his PhD degree from IIT Chennai. Currently, he is also a member of Board of Governors at NIT Trichy. He has completed quite a good number of sponsored projects received from MHRD Government of India. He has published more than 125 journal papers and also presented papers in over 120 conferences. He has received many awards like Best Paper Awards and Best Teacher Award. He has guided so far 16 PhD and 3 MS candidates and many BTech and MTech student projects. He is a fellow and a member of many professional bodies. His research domains basically are intelligent systems engineering, modeling and simulation of manufacturing systems, supply chain management, sustainable manufacturing, e-maintenance and industry 4.0, robots in manufacturing, project management, flexible tooling and automated inspection, etc. For further information about the resource person, you can interact with him during question and answer session, and also you can log on to his personal web page at NIT Trichy for any further information if you require. With this, I conclude my speech and request Professor Kumanan, the resource person of the first session, to take over the session. Over to Professor Kumanan.
Good morning. Good morning. I appreciate the principal in encouraging the department to do such courses. This will help us to interact and then learn state of art, which is very must. And then the knowledge engineering is growing very fast. And then if you are not updated, you will be obsolete. And then especially students, teachers, maybe first teachers or faculty has to get updated so that in turn, they will give back to the students. And the students should be, state of art should be updated so that the employability will increase. So I appreciate and congratulate for this FDP course. I am very happy to participate in this, to contribute to the your efforts. I'll just make the title of sustainable manufacturing because that's a presently need. Every industry is striving. We have a lot of projects on sustainable manufacturing. We tie up with the collaborative projects to Hyundai and other companies in and around us to make them sustainable because it's a demand. That's what the end of the course you'll come to know. We have up to 12 o'clock. I think Raju is 12 o'clock, right? Up to 12 o'clock, we are going to interact. I built up the thoughts. So just watch few videos initially, then we'll have the lecture. So that will prepare you to assimilate the information part with you. Then the end, how to go about. Okay, just watch a video. What really the word sustainability means to. And manufacturing is everybody's subject. It is not, there is no geographical boundary. You can understand over the talk, you'll see it is global. It is global demand. And any product is, we need a global market. And we have to live to global standards. This is what the thought which we asked everyone has to assimilate. And then especially if engineers are to build useful systems through for the world. So we address global. So we'll understand better when you go through. We'll just have a short video, which will take few minutes, 5 minutes or so on. That will help you. You may not be initially get through, but later, the end of the course, if you are able to thoroughly know what we mean, or what we talk, or what is really the sustainability is, then it is a success of the program. Okay, we'll go on. This video audio is there. Raju, you have to follow it up.
Yes,
Yes.
yes, the video is there. Yes.
Yes. It's
Video,
on.
audio also is fine.
Within the space of just a few decades, the term sustainability has made an extraordinary rise to fame, going from the fringes to the mainstream, as it has become one of the defining features of 21st century reality. Today, the term sustainability encompasses a whole paradigm shift to our understanding of the world and our place within it. This new paradigm of sustainability is set to have a fundamental and pervasive effect on how we manage and design systems in the 21st century, as it will affect all aspects of our economy. This short film explores the ongoing transformation in the structure of our economies as a new form of sustainable economy emerges. The environment represents the whole ecosystem that a society depends upon for various services such as water, materials, food, and energy. When we refer to the environment, we are really talking about a combination of natural ecosystem and human economy, what is called a socio-ecological system. The nature of socio-ecological systems has changed fundamentally over the course of human history as we have developed new technologies, institutions, and tapped into new energy sources. The development of the practice of agriculture some 8,000 years ago represented the first fundamental change in this dynamic, as we created systematic processes for harnessing natural resources based around the technology of farming. At this point in history, humans were dispersed across the continents, and the Neolithic Revolution was ongoing. The Neolithic Revolution was a fundamental change in the socio-ecological systems of the time, where the shift from hunting and gathering to agriculture led to permanent settlements, the establishment of social classes, the eventual rise of urban living, and large civilizations. Before the modern era, people were very much aware of their environmental limitations. Interactions within socio-ecological systems were local in nature. The majority of traditional societies are the net result of a long process of coevolution between a group of people and their natural environment, which created strong limitations to what was physically and biologically possible and what was not. The majority of people were small-scale subsistence farmers. Most of the agricultural production was for home consumption. Agricultural techniques were adapted to local environmental conditions. The amount of land that each family could cultivate was limited by the large amount of human or animal labor that was necessary for agriculture. For thousands of years, agrarianism formed the foundations to many civilizations that rose and fell around the world. rise of the modern era some 500 years ago in Europe created the context for a whole new dynamic in the relationship between humans and their natural environment. With a shift from a dominant pre-modern religious vision of the world to a modern scientific view came a whole new way of seeing the natural environment. This new scientific knowledge got directly applied to the engineering of our physical environment, giving rise to the explosive technological change that was the Industrial Revolution. The Industrial Revolution that started in the late 1700s represented a radical dislocation between society and the ecosystem. Agriculture changed in Europe when the Industrial Revolution made it possible to use machines instead of human and animal labor for work such as plowing fields and harvesting crops. Starting with mechanization, the chain of effects can be traced through as machines gave farmers the ability to cultivate larger areas of land. Farm sizes and worker productivity increased dramatically as mechanized agriculture is more efficient on a larger scale. The mass of society moved from working the land into the newly industrializing urban centers, where large markets for goods and labor came, the new organizational structure prevailing over their daily subsistence, and a new way of life that was divorced from local ecosystems emerged. A major part of this changing dynamic was the harnessing of new energy sources that were greatly more powerful than anything humans had used to fuel their economies before. The large-scale combustion to the energy sources of coal, oil, and gas enabled the transition to new mass manufacturing processes as they shifted from manual to mechanical. These initial changes in technology, economy, society, and ecology set in motion a series of changes, such as increasing economies of scale, commodification and urbanization that through interconnected feedback loops continues to this day in many countries around the world. Although it is apparent that the Industrial Revolution ushered in an unprecedented global human impact on the planet, it has since been dwarfed by the extraordinary exponential growth of human economic activity that began in the mid-20th century. Many of the processes of change that began with the Industrial Revolution reached a takeoff point in the mid to late 20th century, as almost all indicators for economy and ecosystem started changing at an exponential rate, from population growth to loss of species to energy consumption. This great acceleration of economic activity has given birth to a new geological era that scientists call the Anthropocene, as human industrial activity has become the primary driver of changes within Earth systems. The Anthropocene represents a new form of socio-ecological system, one that is truly global in nature, with an unprecedented scale of alteration to Earth's core systems, such as overall biodiversity, climate, or ocean acidity. After 1950, changes in major Earth systems became directly linked to changes largely related to the global economic system. This is a new phenomenon, a truly profound transformation in our socio-ecological systems, one that we are far from understanding the consequences of. Within the course of just a few decades, we have transitioned from being a small world on a big planet to being a big world on a small planet, an extraordinary transformation. A switch from making limited ad hoc interventions into ecosystems to becoming the primary drivers of change within the biophysical processes of the entire planet. These changes and their potential consequences are being made most explicit to us through the changes in climate that we are currently witnessing. Through human industrial interventions, the feedback mechanisms that stabilize and regulate Earth's systems have been significantly degraded, both within local ecosystems and increasingly on the global level. The breaking of these stabilizing negative feedback loops increases destabilizing positive feedback that makes the system more unstable and thus generates more extreme events, what scientists call global weirding. We have benefited for over 10,000 years, since the beginning of the Holocene, from Earth regulating itself to create an environment conducive for human economic activity. The Anthropocene is a recognition that this stable geological era has ended, that because of human intervention in the biosphere, it can no longer stabilize itself within the same equilibrium that has benefited societies in the past, that the global economy is now the primary driver of change within ecosystems. The name sustainability is derived from the Latin word sustinere, meaning to hold, and sustain, meaning to maintain or endure. Sustainability then defines the ability of a system or process to endure over a period of time. How sustainable something is can be understood in terms of its overall efficiency, in terms of how effective the whole organization is at operating within its environment. When a system becomes inefficient at operating within its environment, it consumes more of the available resources and produces more entropy or waste, rendering it unsustainable. Sustainability is, though not a property of a thing. Things in isolation cannot be sustainable. Sustainability is more what we call an emergent feature of whole systems. It is not so much about the parts as how the parts work together to enable effective overall outcomes. For example, an electric car is not really sustainable if the power system it is running on imports coal from the other side of the planet to provide it with electricity. Or likewise, if we build an eco-home in the middle of suburbia where the inhabitants have to drive a long distance to do shopping or take their kids to the park, this again will not achieve sustainable outcomes, because we are simply optimizing individual parts without optimizing the whole. It is precisely because sustainability is about a relationship between a whole system and its environment that it cannot be achieved through optimizing individual parts, but instead requires us to look at how whole systems work, how all the parts are interrelated to enable the emergence of an efficient overall system, and thus sustainable results. This is to a large extent why sustainability presents such an intractable challenge to our existing institutional framework. Traditionally, we take a very analytical approach to management. We break systems down into their parts, analyze the parts, and try to optimize them, thinking that if all the parts are working, then the whole will be working. In relatively simple systems, this kind of reductionist approach can work, But in something as complex as an entire economy or global supply chain, it comes to be more how the parts are interrelated into the whole that comes to matter. If we wanted to try and make a supply chain more efficient, we can only get so far by getting each business to optimize their activity in isolation before we need to look at the coordination across the whole supply network. Often when we focus solely on the parts, we simply shift problems to the whole organization, and because of that, we stay getting the same overall ineffective outcomes and unsustainable results. The industrial age management methods and institutional structures that we inherit today are designed to take an analytical approach, breaking problems down, solving the parts, and then putting them back together. Sustainability is, though, a complex and holistic challenge that is not amenable to this method. Although optimizing for the parts may be important in many circumstances, it is really designing and managing for the whole system that is ultimately required to achieve the end result of overall sustainability. Whether we are talking about sustainability with respect to the natural environment or with respect to social institutions, an unsustainable system is one where the value and integrity of the whole organization is being systematically depleted. All organizations require both effective parts and effective overall structures for integrating those parts into a functioning whole. When the integrity of the whole becomes reduced, then the system becomes unsustainable. When the social capital within a society, the trust within the social bonds of the community, becomes depleted, it is only a matter of time before an event occurs creating a crisis that would have easily been resolved given a normal level of trust within the community. And this is the essence of sustainability. It is not a thing, it is the value and integrity of the whole organization that is required to maintain it over time. Whether this is the value of the social bonds within a society or the species diversity that forms the food web within an ecosystem, a sustainable system is one that is integrated into a functioning whole organization. We traditionally focus on the parts in an organization because they are much easier to touch, quantify, and manage, while the value in the connections that interrelates them into an effective whole typically cannot be touched or broken down into individual discrete parts, and is often much more difficult to quantify, making it difficult to manage through our traditional methods. This value of the whole is nonlinear, meaning it is distributed out across the whole organization. It is not one species that maintains the diversity within an ecosystem, it is all of them. It is not the closely knit bonds between people of a similar background that maintains a resilient multicultural society. It is more the distributed weak ties between people of different backgrounds that ensures the overall integrity of the community, its resilience and sustainability. It is this integrity of the whole ecosystem or society that represents the infrastructure or fixed capital that supports and enables it to operate effectively and provide people with the derivatives they value. And in managing such capital, one cannot look at and measure one single connection or one single creature. One has to look at all of them. This is the nature of nonlinear phenomena. It is because these resources within an ecosystem, economy, society, or culture that ensure the functioning of the whole and its sustainability are distributed that traditional centralized management methods are ineffective. Whenever we manage for the parts without managing for the whole, we eventually deplete the integrity that supports the whole and end up with unsustainable outcomes. At the beginning of the modern era, we inherited a natural environment and a set of social and cultural institutions that evolved over millennia without our full understanding or appreciation of them. With the accelerated growth during the 20th century, we came to affect the structure and makeup of these whole systems that were providing the natural and social capital supporting our modern economy. So much so that today they are no longer self-managing. The requirement today is in understanding these macro structures, how they work, their value, and developing organizational structures that can appropriately manage them. Sustainable development is a form of development where we manage both on the level of the individual technologies and organizations, but also on the level of the system as a whole. This is why achieving a sustainable form of global economy will take us into a new world of complexity, because we have to look at, account for, and manage whole interconnected socio-ecological systems in order to achieve overall sustainable outcomes. What gets measured gets managed, and managing for the whole means accounting for the whole, what is called full cost accounting. Our traditional approach to macro-scale environmental management has been exercised through a top-down centralized model driven by government institutions and based on a paradigm of environmental conservation. But this is no longer relevant in an age when industrial activity has become an embedded part and central driver of change within virtually all ecosystems around the planet. Ecosystems management can no longer be an ad hoc solution patched into the side of the economy. This new context requires that it become a central part of what the economy is and does, and this requires accounting for and incorporating both social and natural capital in market structures. Economies function as distributed management systems. Through the negative feedback loops of the market, they manage whatever it is that people value, can quantify, and exchange. Until very recently, we have only really valued the derivatives of ecosystems, the water, food, minerals, etc., in terms of their utility to which we could ascribe a financial value. Through industrialization, industrial and financial capital has grown, and ecosystems have become degraded. Today, the limits and scarcity are not in lack of human-engineered systems, but in natural capital. In the industrial age, we had a scarcity of people and capital, but an abundance of natural capital. Today, we have an abundance of people and goods, but scarcity of natural capital. So it is now not industry and people that need to be economized, but natural capital that we need to be using more efficiently and creating an economy to do that. Completing the process of industrialization means people's value change subtly but importantly. At this stage in economic development, the scarcity is no longer in the derivatives of ecosystems, but instead the functional integrity of those ecosystems. This integrity of the ecosystem can't be fully measured in terms of monetary utility. Rather, it requires a different kind of capital called natural capital. Using economic and business models to manage ecosystems means firstly understanding those ecosystems and the value of their integrity, and then developing accounting and exchange mechanisms based around this. Ultimately, this means building a new dimension to the economy, a new value system for the quantifying, exchanging, and accounting for natural capital. This process of incorporating the inherent value of ecosystems into economic metrics has already begun and will likely intensify in the coming decades. Since economies are always about people and what they value, as the context changes, as those values change, and as the nature of the resource that needs to be economized changes, so does the economy adapt. But this adaptation won't simply fit into our current economic model. It will require that industrial age economic structures evolve into a more complex, multidimensional form. Feature to our existing industrial economy, driving unsustainable results. This linear economic model is captured in the popular description of the economy as a process of take, make, and dispose. But as the economy has grown and reached planetary limits, inputs are appearing more limited, and outputs have become increasingly detrimental to ecosystems. As limits are increasingly met, the emphasis is shifting from gross throughput of material and energy to the internal organization through which those resources are utilized. This new form of economy is called the circular economy, built on the idea of feedback loops that things don't just disappear. Materials and energy go on existing after we use them, and this can be a massive source of value. The circular approach is a concept that has risen to prominence and takes its central insights from living systems. It considers that our systems should work like organisms, processing nutrients that can be fed back into the cycle. From this perspective, a sustainable economy is one without dead ends, with solutions in a sustainable economy built on closing loops between different energy and material flows and converting them into cycles. This nonlinear life cycle view to products and processes necessitates a more complex, holistic view of the systems we design and manage. One that looks for the synergistic connections, works with feedback loops and whole systems instead of discrete, one-off products. Developing a truly circular economy requires diversity and the interconnecting of different systems. Systems and processes that are all the same consume the same resources and produce the same outputs, without the capacity to cycle them between the different elements. It is only by connecting different systems in the right way that we can harness their differences to create synergies between them. Diversity has to be built into the structure of the economy, with different processes and systems coexisting and thriving off of each other's differences. A sustainable economy is one that does not just manage for things, but for how those things are interconnected and interrelated to form synergies that enable the continuous cycling of resources. A sustainable economy is a dematerialized economy, where innovation is focused on delivering greater functionality with ever less material demand. One that can deliver more services with less stuff. One of the most environmentally destructive elements to the linear economic model has been its incentive structure that drives businesses to overproduce and people to overconsume in what has come to be called the consumer society. The industrial model was based on the mass production of tangible products that were pushed out to end users. Mass production meant that companies had to sell en masse, which gave rise to mass marketing and the creation of a consumer culture that went global with globalization. In this product-based transactional paradigm, there was a strong divide between the producer and consumer around the point of transactions due to the fact that both customer and producer had different incentives and motives that ran largely contrary to each other. Over the past couple of decades, with the rise of information technology, has come a new model to value delivery called the services economy. A services economy is one where the focus is on the service delivered, the actual outcomes of a process. It is based on the system's delivered functionality instead of the amount of resources consumed in the production of the product. By shifting the producer's revenue stream away from the production of products and focusing it on the delivery of functionality, servicization is a powerful approach for breaking the core dynamic driving the consumerist economic model. With servicization, ownership of the product stays with the producer, and its maintenance likewise remains their responsibility. In such a way, they are incentivized to produce less while delivering more functionality. The end result is an alignment of the interests of the end user with producer and sustainable outcomes for the overall system. Services are really about access. The idea that people want access to services instead of simply the ownership of products. This is why the services economy goes hand in hand with networked information technology. Information technology and online platforms enable us to easily and cheaply coordinate the exchange and temporary usage of resources, thus working to make access easier and cheaper than ownership. In this way, extra capacity can be created through more effective organization instead of actually producing more products. A sustainable economy would be one that is able to focus its innovation and resources not on producing more products, but on delivering greater functionality through the intelligent coordination of existing resources. A sustainable economy would be one where we manage for the whole life cycle, where systems are adaptable and resilient, capable of evolving in response to major changes in the environment. Our economies have co-evolved with the natural environment over centuries and millennia. Many of our industrial systems are adapted to normal operating environments, but these normal environmental conditions may not be present in the future. The natural environment is changing in very profound, unpredictable, and most likely irreversible ways. Within this context, there is a manifest need to shift from systems that are optimized for efficiency within stable and predictable environments to those that have a much greater level of adaptive capacity, resilience, and are capable of evolving to meet new requirements. Whether we are talking about technology infrastructure or social institutions, the centralized systems of organization we developed during the industrial age are inherently static. They are built once and then go through a linear life cycle with limited capacity to renew themselves. They were not designed to evolve. The challenge of achieving a sustainable form of development is shifting the emphasis from discrete one-off products to looking increasingly at how they can evolve through their full life cycle. This is a fundamental switch in paradigm from designing systems that are inherently degenerative over time to systems that are inherently regenerative. A central challenge that sustainability presents today is in developing organizations and technology infrastructure that have built-in mechanisms to enable the evolution of their overall structure. Sustainable organizations are organizations that can evolve over time. They do not just develop on the micro level of the parts changing, but they are also able to successfully navigate change on the macro level, allowing for the whole system to change. Responding to systemic change requires building evolutionary mechanisms into the fabric of organizations. Unlike our traditional centralized mechanisms for regulation that can respond effectively to relatively small-scale changes, evolution is the only way for a whole system to respond to a macro-level change. Evolution is a distributed process. No one is in control or can be in control. It is a process whereby many diverse possible solutions have to be tried before the best solutions can be identified. It is a process that involves both diversity but also interaction between the system and its environment in order to identify the best options. Much of our systems of organization are built on a linear model where we try to externalize any form of nonlinearity as it is inherently uncontrollable. In the process, diversity is dumbed down and pushed outside of the organization. The end result is a short-term efficient system, but one that no longer has the diversity and mechanisms for generating overall transformation, thus resulting in a linear life cycle and unsustainable solutions. Developing solutions that can endure over several life cycles means recognizing the need for this evolutionary process and the need for the diversity that fuels it. The challenges presented by the environmental crisis and sustainable development are of a kind that we have not seen before, and we do not currently have coherent solutions to. As a famous person once said, we can't solve problems by using the same kind of thinking we used when we created them. Traditional thinking, institutions, and management methods that created the sustainability crisis will not solve it. As such, the development of truly sustainable global economy would involve a transformation in the deep structure of post-industrial economies to exhibit new functional capabilities. One thing is for sure, though, the development of our socio-ecological systems will continue to evolve rapidly in the coming decades. Building this new form of sustainable economy will be a massively disruptive transformation, and there will be many surprises and pitfalls along the way, with many widely divergent outcomes remaining possible.
Yeah, we had a very important documentary on sustainability. This is the best documentary I've ever seen, especially to understand sustainability. Audience, hope this would have been a useful one, but it looked a bit long. But they have evolved. How evolution of sustainability has come into picture. So everywhere it was one side. Now there was a feedback, and the energy whatever been used up has to get replenished, and we have to now the state of art is towards renewable energy. We have already coal and other aspects, because everywhere energy is required. The energy is depleted, and there is a source of non-return. If it goes on non-return, the equilibrium is lost, and it will deprive. Okay, there will be a to make it a summary, another short video which help you to understand what is the role of manufacturing into it. It is global, and it is a whole system. The whole system has to be geared up, and manufacturing has a very great role in building sustainability, because though the manufacturing has helped us to in agriculture, harvesting, industry, domestic goods, transport, any work, manufacturing has a role. So manufacturing has to get geared up to sustainability. So every other product what manufacturing is doing, or whatever it is producing, it will also be sustainable. So that is the watchword, and it is mandatory requirement for any factory. The consumers are demanding, because consumer knows, or the consumer takes a responsibility of keeping a sustainable world, so that in our own time we lose the resources, and then henceforth the coming generation what will leave. That is the question. Now we'll go to another presentation.
What is sustainability? One of the more common definitions of sustainability.
Are you receiving the audio and video?
Yes, sir.
Sustainability used worldwide is from the UN Brundtland Commission. They say sustainable development is development that meets the. What is sustainability? One of the more common definitions of sustainability used worldwide is from the UN Brundtland Commission. They say sustainable development is development that meets the needs of the present without compromising the ability of future generations to meet their own needs. So put simply, sustainability is about our kids and our grandkids. How do we live today so that they can thrive and future generations can also have a good life? Our planet has many resources that we depend on for food, for housing, and many of those resources can replenish. You can cut down a tree and grow new trees. You can catch fish and there will be more fish. But that only works if you do it at a rate that these systems can replenish. We call that the replacement rate. You could think of it as a bathtub, and you're draining the bathtub and filling the bathtub at the same rate. And if you do that, then the level of the water should be able to stay stable. We call that equilibrium. It's not that you're not using any resources, you are, but you're doing it at a rate that the systems are able to stay somewhat steady. Right now, and over the past few decades, what we're seeing is that we are consuming resources much faster than the replacement rate. And the result of that, draining the bathtub faster than filling it, is that those levels are going down. We're seeing fisheries disappearing and other ocean life. We're seeing forests disappearing. Of course, everyone is familiar with the impacts of climate change and, other impacts of this level of consumption, plastics in the ocean, all of these problems. So ultimately, sustainability is about understanding how all of this is connected, understanding that when you make a decision to buy a smartphone, you are impacting someone's life on the other side of the planet who's involved in mining the materials to put in that smartphone. So sustainability is about systems thinking. One of the other big frameworks that we use to talk about sustainability is the 3 E's. In business, we call that the triple bottom line. Some people call it the 3 legs of the stool. And that's environment, economy, and equity. And it's not just about understanding that we need to manage all of those. It's understanding how they're connected. So if you only look at short-term economic profit, then you're not going to end up with a thriving economy in the long term. If you're only looking at conserving the environment without thinking about economics and understanding, how people are making their livelihood, you also may not end up with a thriving society. And if you aren't looking at equity, you're going to end up with a few people that have most of the resources and many people who are hungry and not living a good life. And that's not really a successful human society either. So sustainability is really about addressing all of those and understanding the connections between them.
Yes, we could. Now we'll get on to that with that introduction. See, another an hour we'll be discussing about manufacturable sustainability. Are you able to see the PPT?
No, sir, not yet. Yes, sir, we can see now.
All right.
Yes.
Yeah, we'll go through the content and again how industries are working on the sustainability. Industries, manufacturing industries are going through sustainability, and we'll understand now the intricacies. So you would have heard the participants. I like to draw the attention of participants. Can you, when you go through the documentary and again a summary, which is a objective of sustainability, what are the words you get through? Can you name some participants, please? Can you unmute their mics? Can they do themselves? Raju, the mics are.
Yes, sir. They can unmute themselves and they can speak.
They can unmute and call. Can I? Are they there?
Yeah. They can unmute themselves, sir.
Yes. Have the participants, one of you can just tell what was the documentary is about? What did you get? Is it new? What is that you inferred from information? What you got from it? You can introduce yourself and the communication should not be one way. I think, except me, nobody is.
Hello, sir.
Yes.
Sir, this is Canute Sherwin from Department of Mechanical Engineering, St. Joseph Engineering College.
Okay.
Sir, one important thing what I observed through the video is 3 E's of sustainability.
Yeah.
This
Yeah.
environment, earth, and equity.
Economic, ecology. Okay, these are E's, many E's. We are going to discuss about that. What else? Environment. That is
Yeah,
one of the
environment.
word been used because environmental friendliness. Why environment is good, Canute? Anyone else? Good. Your break. Ice breaking is done. Any one more I like to. Normally in the class I used to call names. I have all the names here, but I don't want. Let them come voluntarily. Some of them does not have a mic. Those who have mic can try. You can unmute your mic and then converse. So with your the documentary is given to create a platform so that I could build, because sustainability is being discussed over years. And a lot of review papers we ourselves have conducted. We have PhD students doing sustainable measures in industrial sustainability, and then for few of our students, sponsored students from Hyundai Motors, they did a framework of sustainability and tried them in their industry. So we have a rich, still almost some 6 to 7 project attempts are done on sustainability measures, and then sustainability industries, because it became an essential ingredient for today to survive. You want to be competitive, you should be sustainable. And it is in favor, it helps, a lot of advantages are we are getting it. I'm going to share a written material, article, which you'll go through, and then you can interact with me. That will help you certainly to say something about at least awareness of sustainability. Whatever activity you do in manufacturing, maybe it's a design process or marketing, whatever you name it, or customer interaction, anything, no, you have to go into a sustainability conscious. With sustainability conscious, you have to approach. That is a must. It is a mandatory. And then if your product not sustainable, you will not be accepted. That makes the essential in another topic. And we are making a subject for our BTech and MTech students, because the engineers has to know they are the one maximum contributors, or they can contribute in building sustainability, as they have done in the agriculture mechanization or industrialization, then globalization, whatever you name them, they are all done by engineers. Now, even to recover back, or replace the resources or sustain the resources for the world to come, is done only by the engineers, because they consciously do into their product, into their activities. Okay, one more participant, please come out of the shell so that we'll continue. Any in-house participants are there, Raju?
Yes, sir.
If nobody is speaking, you have to speak, Raju. You should encourage. See, in those participants, you should ask them to interact.
Yeah.
tell them what, see, it is about half an hour and it is certainly a useful documentary ever I have seen on sustainability. And so the build-up was so nice, and then how the sustainability is essential, evolution, conducting the world economy, globalization, products, customers, interaction. And you could see there are some watchwords are there. I like to get back. Certainly you would have watched it. If you continuously watched, you would have seen certain words which are must for knowing sustainability. What is that flow? Every time we see a flow. What are the things flow?
Participants, you can unmute and you can interact with the
Yes.
speaker.
You know some names, call them, Raju.
Yes.
Otherwise, it become one way. See, communication is two way. Until otherwise, you know, you are with us, then it will not be useful. You have your students there, Raju?
Yeah, staff members are there, sir.
No, your students,
Students
PhD or PhD
have registered but not
in
seen
this.
here.
See, the coordinators in the institute is taking a lot of efforts. And normally, of course, we also learn, because when we coordinate information, collect the information, we work along. We have my scholars with me. We are working for a week to make it a success, because getting into a title and then knowing them, the state of art is not easy. Okay, and this is the opportunity for the participants, which is we get readily possible, and then any type of questions you like to clarify, so that your knowledge will be sharpened. Kiran R has a mic. Kiran R, are you there?
Noel, do you have?
Yeah, Noel has the welcome. He only welcomed us, right?
Yes.
Noel, you
Yes,
have
sir.
something? Yeah, please.
Yes,
What
sir.
is it? I think you should have watched it thoroughly.
Yeah, I was waiting for others to ask.
Not a problem. Nobody is there. You have to make up. Otherwise, Raju has to speak.
Okay, sir.
Okay. What was that?
Sir,
I said I had a question. No, what there were a lot of flows on.
yes,
What
sir. No,
are that?
no, my question is like, especially when the topic of sustainability comes, how will developed countries try to implement this particular sustainability concept? Because they have the money. They have the money to implement it.
See, first to understand, developed, underdeveloped is not a question. Many a time, some of the thing, like we have e-media. Sometimes, e-media do not work. See, everything goes well. Now I have internet, power, all that is okay. Otherwise, we will get delinked. Energy is information technology, but by personally you go to a board and then write it, nothing stops it. Communication, paper communication. So that is a secondary, but we make use of it, because you're coming to Mangalore and then collecting all of them, sitting in a place is very difficult. Now we could communicate knowledge at your doorstep, at your mobile. Maybe some of them would have put in mobile also. I do not know. They would have checked in mobile. Okay, this is what the Corona taught us. We could do the classes online, and it was very effective also, because everyone is linked now. Another point is they could not get in and leave the mobile and go somewhere and do other work. Anyhow, they are the losers. But there is, you see, energy consumption and material are made as product, information, energy flow, information flow, material flow, these are happening. thoroughly throughout, whether you like it or not, it goes on. It goes on. That's why you see that that's a traffic flow they have been showing. How the traffic, everyone has the track. If they miss see, they should go with they go very fast. If the destination, if they're not having a clear destination or direction, how fast they go, there's no use at all. Simply drive fast, what will happen? See, they have to go, they have a goal, with the goal they move. So that's what everywhere you could see. And then certainly we spend energy, information. There is a material being made. See, everyone is, see, we say the world is of materialistic world. See, it you have to get instantly arrive. You see that there was a small example. To make a country wanted everything to be electric. Okay, we also drive 2035, whole India will be electric vehicle. But to make an electric vehicle, the essential thing is battery, especially lithium-ion battery. Who will make lithium? Where the iron ore is done? What type of manufacturing is? So it somewhere you have to pollute. So there should be a balance. That is the thought. Anyhow, thank you for sharing. Now we'll go ahead. Maybe end of the class, I think others should be ready to just watch out and then you have to interact. Okay. So the first point of sustainability become very alert is we have, this ozone layer depletion. There is a hole in, so that the cosmic rays are coming and affecting. A lot of seasons have changed. Recently we are very sorry about that earthquake, Turkey and Syria. You see, someone has predicted it and still they could not, even if you predict, they could not manage because it is a natural catastrophe. Like so many things happen because we don't preserve the world. Nobody is conscious about. Now people are conscious about environment. We should be friendly with environment. If you go against nature, nature will create disaster, which no one can tolerate. No government can tolerate, or no one can manage that. That is important. We should be very consciously handling the environment. How we react, how we interact with the environment become a question. Then you should have a policy. What is this policy about? A policy with which you make, sell, or do business. So there is a policy, there is a guidelines which you have to go by it, abide by it, policies. So the policies are to be sustainable and environmental friendly. This is what we are going to see, what is how to draft a policy. Then scale, what level you are doing, what level you are interacting with the environment, or how you are sustainable. That's also a scale. Scale is a measure. See, when you are not able to measure the quantity, you cannot maintain or sustain. That's what the phrase told in the documentary. In middle of the documentary, if you have watched carefully, they've said everything to be measured. And then, there's a saying, even if you pour it in the river, you should measure it and do it. Because you think a river can accommodate anything. Now you see the rivers, every city is polluting the river. And recent survey in Tamil Nadu, 32 rivers are dead. No, dead, they say dead. Dead means what? There is no fauna, there is no flora, there is no life in it. If the rivers are dying, that means civilization will die. People have to die. Civilization has grown with the rivers, every other side of the river, because that's where living is possible. So in and around us, there are birds, animals, they live together. That shows they are the indicators for how sustainable that place is. You could see that. So the what scale you are getting affected, what is the area you are going to work on? These are some of the aspects. Then we think about sustainable development. Whatever you do, you should be sustainable. That's a question. So these are some of the phrases we need to know. Environment. The environment is circumstances, objects, condition by which one is surrounded. So the complex of physical, chemical, biotic factors, you have seen the documentary, how so much of natural, how we have developed, how man has civilized and how we have evolved. And then, so on we are all organisms, we are all ecological community. So ultimately determine its form and survival. The aggregate of social and cultural conditions that influence the life of an individual or community. Okay, this is what environment is. The totality of surrounding conditions are felt and modified in three main ways through the flows of materials, energy, and information. So fundamental spheres of influence for sustainability. These are the things which are creating, we have to take control or monitor about. These are done. We consume in large, more than required energy, or we consume materials more than required. And we have no information sharing more than. See now mobile, if it is useful information is okay, but it give a bulk of information which actually distorts our goal. Our endeavors are distorted. So it's very important to control them. So a course or a general plan of action to be adopted by a government, a party, a person. Now the whole world have a colloquium where it says what is to be environment. And they have a statutory. Suppose if your product is not environmental friendly, you cannot sell in the market. That such a statutory requirements are put as a policy. A selected planned line of conduct, the light of which individual decisions are made and coordination. So this is what Webster Dictionary says about policy. So we have this conceptual scaling. Then what type of decisions, every aspect, every point, you have to take a decision. The decision should be bound, certainly cost-effective decision we take. It should be cost-effective, and similarly, it will be environmental friendly. Economy, environment, and ecology. This all aspects have to be taken in your decisions. And then you have values, ideology, strategies, and they are interrelated. Then comes the development. Before getting into development, scaling, decision-making, values, all this to be understood. What type of scaling? An ordered series of graduate quantities, values, degrees, relative magnitude. So how much of quantity, how much of energy is used? How much gallons of water is used to make a car? These are some of the questions which has to be answered. And do you say I have improved, I'm sustainable? That means you would have cut down the usage of water, cut down the depreciation of coal. Coal is energy, essential energy for your power. I mean, it has been consumed. So you see in your that document, it was seen lot of excavators, excavating mines. So to make material, they excavate whatever. So now there are some materials which are already distinguished. We don't have such material. We cannot excavate. Coal is one. Coal is such one. So coal-fired boilers are no more existing. Now we are going to have nuclear. Nuclear is still a large amount of safety is required. And then so that's about scaling. Physical, geographical, based upon size, dimension, ecological, individual, community and population, and jurisdiction, local, municipal, regional, federal, global. And we address only global. But anyhow, we have to be, it is slowly scaled down to local also. But we have to address global. So in your scaling, you see that how the marks are. Globally, you take earth, continent, country, province, region, municipality, neighborhood. This all, everywhere it should be addressed. Everywhere it is addressed. You know, this planting of trees, preserving of water, conserve energy. These are marked everywhere. You could see, and then now we see this non-degradable items are banned, and then government makes statutory, and then they seize in our shops. And then I have a practice of not taking plastic bags. We used to. So personal commitment, if you have, certainly you could be contributing a small scale, maybe a small scale, but every one of us is a larger community. We can do so. So the exercising of this power, the region with which the power is valid are like that. See, some are global, world requirement, and then they have a World Forum on, of course, when you know G20 or any type of international leaders, when they meet, making environmental friendly or protecting the globe, sustainability in ecology or environment become the order of the day, and it is being given priority, because when everyone started mercilessly or thought without thought, if they start destroying and misusing the energy source, we cannot replenish them again. So no way you can replenish. So there is a talk like that. No, you can break the hill. Can you build a hill? You can excavate sand. You can excavate coal. Can you bring coal back? So that is non-replenishable. Instead, you look to renewable energy like solar, wind, which are natural sources. We could recycle. The bathtub was shown there where water is spilling. So water has been put in. So there is equilibrium. There should be an equilibrium. Okay. So then comes World Commission on Environment and Development. This there is a center which makes meeting the needs of the present without compromising the ability of future generation. Okay, whatever needs you have, you are justifiable, but don't compromise on the future generations, or do not. Okay. So this is a sustainable triangle. Okay, it is shaded like this. 3 levels are coming: environment, economy, and society. So this they have classified. So in environment, okay, biodiversity, materials, energy, biophysical interactions, these are being taken care. It has to be a trust attached for measuring or building or developing sustainability. An economy, okay, employment, technology growth, they are all interactive. They influence. There is an effect. If you are not taking care of sustainability, this will get hurt. So you know, there some of the countries are already having no capacity to buy, and then inflation is there, and natural resources are not available. Food, water, there is a great scarcity. They could not buy them, even if you have wealthy, you could not buy source because it's not available. So these are some of the aspects which are interlinked. So the quality of life, equity, human diversity, institutional structures, political structures, these are all influential. They are all factors which are going to affect. You see that how complex it become. Even individual society, so many aspects are there. You have your economy, you have, then you have environment. So they make it more complex. So ecology, economy, equity, they model. And then you see their society, economy, environment, health is the prime. Keeping the health, they are very interactive. Healthy means when the health is like environment. It is talking about health, not personal health. Personal health will come on environment where he lives. You know, there are in our own country, India, where there are states, there are cities where you cannot inhale air. It is not the level of purity of air is very, very dangerous, and some of the cities not habitable. It becomes not inhabitable. So they are all mark of non-sustainability. Non-sustainability. The reason is could be heavy transport, breaking of material, not recycling the material, not taking any conscious about their efforts. So these are some of the problems. Depletion of finite sources, fuel, soils, minerals, spices, overuse of renewable resources, forest, fish, wildlife, fertility, public funds, pollution, air, water, soil, inequity, economic, political, social, gender. These are all problems. The threat to sustainability. If you are not having any defined regulation or conscious use of this, you cannot bring sustainability. Okay. So, and many things are endangered. I said minerals are endangered. Species are endangered. You know, if all your rivers go die, or your lakes are dying, and no natural resources, inhabitants come, and this, you know, the some of the places where you get honey, you know, because of it goes to the flowers, and the bees takes the honey, and then so once it was a they could make a sweet honey, and they could make enough number. Now there is not, they are not capable of doing, because you have depleted the source. So what are the solutions? Certainly there should be solution, because when these are the problems, we can take care of. This is what the documentary showed, very detailed. Then cyclic material use of recyclable materials. Okay, save reliable energy, conserve energy, use renewable energy, substitute energy, life-based interest, health, creativity, communication, coordination, appreciation, learning, intellectual and spiritual development, where sustainable. So two key concepts become equity and limits to growth. You should understand these terms. The concept of needs, particularly the essential needs of the world's poor, it's all equal. See, the world, it is not, I have a, there is no geographical location. See, the world globe is one. There is no in air, no, for air moving one place to another, or monsoon or climate or weather. See, they have no geographical boundary. They don't keep boundary. They cross. So birds, they cross. Animals, they cross. They don't never keep a boundary, except for man. It's good. Boundary is good, so that they could safeguard and keep them well. See, whatever they are bounded, in that boundary, they should keep them well, so that it doesn't affect the other. You know, this in agriculture lands, they are all enormous land. Everybody had a part. It was suppose in the middle of the that area, a person has a small 1 acre land, and if he does not take a pesticide or watering, or does not season his soil, or do a plantation properly, it affects others. So normally they will have a group of a society like thing, and they insist him to cultivate. And then when everybody is taking measures for pesticide control, they do, and manuring, harvesting, they get together. So the collective responsibility make them a success. So this is what we talk about equity, the quality of being fair or impartial, fairness, something that is fair and just. Equality is contrast to equity. We say a state of quality or quality of being equal. So you should not get confused with the uniform character or motion or survey. Okay. Limitations. Ecological, technology, and social, which affect the environment ability to meet the present and future needs. So already we may be limited. You have to give alternate for that. We are limited. Recently there was news that India have a opportunity for mining of lithium. So there is a great opportunity, they say, but lithium is useful for battery. You know, now the compactness of battery, robustness of battery vehicles depends on the battery. Okay, it has a life of 5 years. Every time you have to replenish. Suppose you are replacing all the diesel and petrol vehicle with power driven, electric driven. You need lithium battery for everything, and every 5 years you have to replenish. Where the source is from, how to maintain them. Okay, these are limitations you should think about. We cannot totally say now people are thinking of hybrid. But you have to think about. You have to think everything should have a solution. It's a problem, but everything should have a solution. But solution should be a sustainable solution. The limits of qualitative and quantitative. So living with the regenerative and assimilative capacity of the planet. So limitations are imposed by the ability of the biosphere to absorb the effects of human activities, adaptability of human, social and political. One such is the plastic, non-consumable, non-recyclable plastics. Everyone should take effort to see these flux banners. That's a very bad culture throughout the country, which are not consumable, non-recyclable. That actually damages. That has to be, and like pesticides, some of the pesticides are not, it is consumed in the plants and food. Now the food quality, that vegetables what you buy or rice or whatever, no, these grains what you buy, they are all more polluted with the chemicals. So economic growth must be, a dematerialization of the economy, less material intensive, less energy. You know, this we are in ATMs. Some of the ATMs say we are eco-friendly. We see only e-media. They cannot take a print sheet. You just watch the balance and all, the code, whatever you want to take, or you get a message in a mobile. Okay, that's all e-media. E-media communication are done. Papers are, because for A4 size a tree is cut. So paper consumes trees. So paperless office, paperless efforts are done. So less energy intensive, more equitable in its combined. Economic growth may be reduced or curtailed to meet limitation imposed by environment and technology. So there are two major gaps are identified, which is in organization level. So it impedes, it means stops or prevents. Narrow mandate, jurisdictional rigidity, lack of communication coordination, lack of failure to make bodies whose policy action degrade the environmental responsible. See, starting from local bodies, municipality, corporation, cities, then next to the state, then to the country. If they are irresponsible, there is no statutory requirements. If they don't, it lose means certainly you are going to you have a degraded society, and your place, your own place will become inhabitable. So non-renewable and renewable energy materials. So we have high throughput waste and toxins and heat. So one way flow of materials and energy. We keep on consuming. Okay, we heat up, and then waste and toxins are evolved. So we should have a conserver. How you have to do a sustainable civilization, conserve society, and who has the role of doing a sustainable civilization? Engineers. Who are the engineer? Maybe a chemical engineer, or a civil engineer, or a mechanical or production engineer, manufacturing engineer. So they use energy, they use materials. So they should be renewable, energy efficient, waste minimization. So low quality heat energy, low throughput, low volume, non-toxic waste material. Cyclic flows of materials. So for a sustainable development, consider future and present needs when making decisions about resource and energy use, technology development, direction of investments, social, political, institutional. So your decision making, okay, future and present. Present needs, it is saved. Future, it is reserved. So what are the areas engineers are handling with? Resource energy use, technology, direction. So in the manufacturing also I'm going to very much focus on manufacturing, but this is generic. But even manufacturing is one subset. It could be anything like electronics manufacturing or paper or whatever. Manufacturing has a wider perspective. It could be other field of interest. The goals are common, and this is essential for making decisions. Economy, environment, and society. So traditionally, it is non-participatory, fragmented, but you should now look into participatory. Ecosystem health. This is what our goal is. Previously, it is all are it's not integrated as they do, non-participatory and fragmented. And then traditional is a traditional. Now we have to go to ecosystem-based decision making. This is what sustainable development, a sustainable decision making, a sustainable society. Create a sustainable society, or sustainable product, sustainable manufacturing, sustainable design. This is where we have to do take society, economy, environmental, inclusive. Take a decision, inclusive decision, doesn't affect each other, participatory and integrated decision. So fragmented, no issue are done separately and no connection between them. Integrated, we see now interests are taken, private or public, federal, provincial, regional, municipal, community, the issues are common and it is all involved and then the decisions are taken. So you see in the decision making, we take, normally it's a very reactive method of doing sewage treatment plant, end of pipe solution, where either environment or any one of them will follow. You see, I said no, there was a river in Chennai called Kuam River. It is dead, it is declared dead. No, they tried to recoup and all that because totally mindlessly it has been used and then all the spoils are put in, waste papers are put in. It was a river where people are traveling. Commercial things were there, boats were there. They were carrying things through the river to the canal or to the harbor. It is totally unused, totally dead. Like that, in our state, we have 18 like rivers are dead. That means what? Nobody can stay or nobody use it. Doesn't do the friendliness or eco-friendly. It is inhabitable, and rather it become polluted and it causes more harm to the public. So we have improved to anticipatory change in process, clean technology, environment, and we have taken previously to either one we were doing. Now then started doing both. Now the need of the hour is any radical decision making is in industry. We have to take less consumption, alternative consumptions are put in. Environment, economy, and society. This is what threefold. Environment, and it should be inclusive of environment, economy, and society. Take care of all of them in decision making. Okay, this is an historical example where you see the CFCs are cost for the Freon, otherwise called Freon. They are the cause for the ocean hole, which causes the cosmic rays mean to come and affect the heating of the environment or atmosphere. So that that is now they have taken conscious effort. In 1988, it was 1,000 plus tons. Now it was 0 tons. They replaced Freon. And then across countries, this across countries, they had plants and then they took effort and then they've been curbed. So they used the original process is like this and then they revised the process. So without grease and they have recycled, called re-engineering, We were just trying one thing and then it is causing more harm, more byproducts. It's not environment friendly. You re-engineer such that it will become environment friendly, eco-friendly, and then use less energy, just energy to make. So they did not use CFCs to clean up waste. The finished product is so environmental friendly, recyclable. So this is a revised process. So this still they use. The product is there, still they use, they make, but the only thing is the technology is changed. The technology decisions are economy, environment, and then social based. So this is where they were able to get. You see that how the decisions have changed. Sewage treatment, industrial process, change in demand or product. Demand for product itself has changed. If they are unhealthy, now it was seen that some of the refrigerant gases are banned. They are banned because it causes damage to society. It's not environmental friendly. Environmental friendly products are removed. Okay. So complete redesign. So interaction among values, ideologies, and strategies. Values are individual, cultural, social, spiritual, moral, and then ideologies, industrial capitalism, Marxism. So many things are there. They are all tuned to make holistically with the environmental values. Okay. So they have appropriated the technology with principles of durability and efficiency. So the new technology are brought in. So environmental ideologies were technological optimism, sustainable development. The Brentford Commission has given a lot of inputs. Social ecology by Murray Bookchin, deep ecology, like that. So these were ideologies, and then they made it as a strategy. Ideologies by itself doesn't help. It is made a strategy, what to do. Single issue lobbying, permanent organization, then alliances and coalitions. So we have to move with the paper. Rhetoric means beating the bush or great thing, we need to sustainability. But it has to get realized. See, everything was in paper, doesn't help. It doesn't improve or clean. We want a clean society. We want a clean air. Come on, we want a clean water. That doesn't, by just telling them 2035, India become a clean, no pollution, pollution will go down. These are some of the phrases which doesn't help. It has to go to reality. How to go? So the principle has to be transferred as a policy. Policy means you have to, these are the policy you have to adapt. This is a policy made by the concerned organization statute as a statutory, then it is being practiced. Even to practice, no, you have to make strict vigilance and then make them practice. Then only things will happen. So these three are going to be scaling or the principles of it has to go through the ideologies, then made as a policy, then as a strategies, and to be practiced. So you have to take in every decision making, it should happen. So there are many literatures followed. I have listed them. Okay. So guideposts for sustainability. Activities are sustainable when they use material in continuous use materials in continuous cycles, use continuously reliable source of energy. Now we see a lot of solar plants, and we have the office what I am sitting is 1 kilowatt power energized by solar. We cut down the energy, electric energy. We stay to use a battery and then use a 1 kilowatt under my office roof. It is done. And my house, it is 1 kilowatt. You see, every effort, single effort is possible to do. You can do them. Encourage desirable human rights, equity, creativity, communication, coordination. Okay. Require continual inputs of non-renewable resource. Use renewable resource faster than the rate of renewal. Cause cumulative degradation of the environment. So activity is not sustainable when activities are sustainable when they do this. Activities are not sustainable when they require type of thing, degradation of the environment, require resource and quantity that could never be available for people everywhere. So these are the things. Okay. So you have in nutshell, you see this social, environmental, economical aspects are taken. We have, of course, this is the general one. But for manufacturing, we have to take a system which are manufacturing system, which they done the processes and then make products. You see this? Environment, economic, and social aspects are taken. But you have been discussed in the documentary and your data. Okay, so we have other subsets like sustainable manufacturing can done by green, friendliness, recycle, reuse, reduce, RR, 3 R's. Recycle, reuse, reduce. Lean manufacturing, waste reduction, sample. You can do any efforts. You can put the efforts on lean manufacturing. Lean is just energy required to make. Don't waste. Don't do overdo. Okay. Then recover, redesign, remanufacture. This is called sustainable manufacturing. You see that processes are look into cost, then energy consumption, waste management, operational, personal. This was taken close to, see there, sustainable is, the development is the global and world over. There are numerous activities we have to take care of. There are in agriculture, there are medical health systems, and then water treatment, sewage treatment. These are the public health systems. Here we have taken manufacturing. Of course, manufacturing is allied with other groups also. But I am just closing to the manufacturing where we are taking efforts to make manufacturing a sustainable. That is environmental friendly, green manufacturing or lean manufacturing, whatever you name them. You have sustainable manufacturing, optimization of production, process and technique, increased energy efficiency, producing less pollution, industrial symbiosis, design for manufacturing. See, for example, I'm focusing on a welding process. If it's a welding, take up only one process. Suppose you have a major work is welding, a fabrication industry, then you say minimum energy consumption, minimum material wastage, minimum resources, maximize the cost saving, highest process. These are some of the goals you can do. If you do all these goals, you are sustainable. You can call yourself a sustainable unit. See, basic relationship between manufacturing and the environment. You see how we are interrelated. Inputs from the environment, operations. We have a process to turn input to products and activities necessary to operate the production process. Facility operation, transport, business travel, staff, and all this. So this is what we are interacting with the environment. We make it lean, and then make alternate recyclable material and make products which are very environmental friendly. Then that's how we are going to contribute to the society. Economy, how we are contributing, society, how we are contributing, and then for environment, we are contributing. See how from traditional we are going to lean, green, and sustainable. Okay, it is innovative and 6 R based: remanufacturing, redesign, recover, recycle, reuse, reduce. Keep this as a focus. That's where we are going to effect it as a sustainable manufacturing. We are from traditional to lean to green, green to sustainable. You see the years from 1980 onwards is the watch, and then still it goes on. Now we have to go. It necessarily you have to be. If you are not sustainable, the customers will not be able to interact with you. Or many agencies have now say if your product is not sustainable. 12 o'clock. You see that's what we listed. Like increasing circularity, smarter product use and manufacture, extend lifespan of product and its parts, useful application. We see where this is called it as refuse, rethink and reduce. Okay, make product redundant by abandoning its function or by offering the same function with a radically different product. Where refusal comes. Rethink, make re-engineering, rethinking, make product use more intensive. Reduce, increase efficiency in product manufacture used by consuming fewer natural resources. Similarly, we have reuse, reused by another consumer of discarded product. Then repair and maintenance of defective products, so it can be used with its original function possible. Refurbish, restore an old part and bring it to update. Remanufacture, use parts of discarded products into a new product with the same function. Repurpose. You know this. There was a project taken as a with one of our students. It looked simple, but I don't know what was the idea. Suddenly he took up idea that rail wheels, once they are worn out, they are discarded. To make a rail wheel, wheel factory would go. You see that enormous energy is spent to make a wheel. Now it is worn out and then it is discarded. So instead, that person took as an entrepreneur, he took them and then he made and found out a material and the way to technology to reclaim. His company name itself called metal reclamation, metal reclaim. So what he did is he relayed the layer onto the wheel and then he found out the machining of that. So first there should be a cladding, it has to get attached to the as the original. So he made like an original, but the cost of it is only maintenance cost. So you could see the rail wheels in India, how many rail wheels to be replaced. He did a good business, and then it is one of the sustainable product now. So this is one of the cases. There are many cases that is really happening. If you focus, you will be able to get through. So engineering can be done now with the attempt is re-engineering. Re-engineering is do the same with a different thought, with the sustainable thoughts. Okay, this is what the another way of doing the sustainable manufacturing. Okay. Now we'll just have how to go about another 10 minutes. We'll see. Okay. Yeah. The voice sound.
How to become a green SME in a
Is voice and video available?
Yes,
Yes,
sir.
sir.
Yes, sir.
circular economy. 99.8% of Europe's private companies are SMEs, accounting for more than 2/3 of employment in the EU 27. Well then, as an SME, what are you doing to become green? How could you become a green SME in a circular economy? Moreover, what is a circular economy? A circular economy can be defined as a system in which production, consumption, and trade are designed to minimize the net extraction of key resources, such as fossil fuels, raw materials, water, land, the environment, and pollutants, along with diminishing negative environmental and health impacts. This video has been split into 3 parts. Firstly, what can you do on your own? What is in your control? Secondly, what can you do with your business partners? Lastly, what is the European Union doing for you? You might have noticed that prices of raw materials are increasing. For instance, since 2000, metal prices have risen by 170%, rubber has risen by 260%, and many other materials are following suit. It's always tricky to put an expiration date on certain resources like, there will be no more silver extracted in 15 years. Yet, what is certain is that companies will increasingly have trouble sourcing raw materials at affordable prices. You'll need to think about improving processes, improving design, improving supply chains. We are all familiar with the old saying, what gets measured gets managed. Well, the first thing to do on your way to resource efficiency is to map your processes. What natural resources do you use? How much do you need? Where could you improve? Material flow analysis can help you to visualize the material flows and losses of all your processes. Take the example of painting a car in an auto repair shop. The left side shows the flow of paint before the analysis. The red arrows show how much is wasted or lost in emissions. Out of 10 kilos of paint purchased, only 1 kilo remains on the car. The right side illustrates how much of this can be spared. If you reduce losses within the paint's preparation and application, and if you limit overspray, you will only need to buy 3.2 kilos of paint instead of 10. Material flow analysis is a good way to reduce material, energy, and water consumption. Going beyond improving existing processes and redesigning products and systems can bring even greater benefits. This is the principle of eco-design, which is illustrated in the following example. A refrigerated truck company managed to reduce the weight of their trucks and semi-trailers by 16%. This brought about other positive changes, such as less fuel consumption due to their lighter trucks. As the German architect Miss van der Hoer said, less is more. Better design is another step forward, expanding the focus beyond materials. Eco-design considers all the main environmental impacts of a product throughout its life. Such environmental impacts include CO2 emissions, soil and water pollution, acidification, and hazardous waste. Based on life cycle analysis, eco-design also gives you some influence over what will become of your product once it has left the factory or shop. Eco-design can make it easier to reuse or recycle your product at the end of its life. For instance, one particular company has designed a laptop that, when it reaches the end of its life, is at least 70% reusable or recyclable. This particular laptop was designed with the support of the EU-funded Zero-Win research project. Clearly, redesigning your products and processes to use less material will benefit both the environment and your bottom line. However, improving your supply chain goes beyond simply reducing quantities. Better supply is also about identifying the weakest points within your supply chain. Take rare earth minerals as an example. Most SMEs, as well as their immediate suppliers, are completely unaware of to what degree they are dependent on critical raw materials. Some tools have been developed to help SMEs tackle the issue. For instance, an example in France can be found at the following address. Furthermore, in a recent report of the European Commission, 20 raw materials were identified as critical, including cobalt, gallium, indium, tungsten, etc. Use one of these tools to check that your main inputs are not on the list. And what if they are? Well, better supply above all means that you should look for substitutes or other sources of supply, such as from recycling. Instead of buying virgin plastic material, you could buy recycled plastics. Instead of buying virgin paper, you could buy recycled paper. Instead of using fossil fuel in your plant, you could use renewable energy. As for rare earth minerals, there is ongoing research and development to find synthetic substitutes to natural elements. Anyways, the changes that you can make will depend on your operation.
See, these are some of the what you could see, recycled plastic, recycled paper, recycled energy. These are substitutes. Getting a substitute is manufactured research. Most of them are doing, and then they are presenting. And the sustainable goal, the goal of sustainable manufacturing, have a lot of research potential. Those who are interested can take up the issue. Like you just watch around, you see that there are material we have. It is shown as distinguished material. See there, some of the materials are 20 critical raw materials are there. So that means this raw material has to be replaced. So that is one of the challenge of research potential. Just to go through so that it will be
Identified as critical, including cobalt, gallium, indium, tungsten, etc. Use one of these tools to check that your main inputs are not on the list. And what if they are? Well, better supply above all means that you should look for substitutes or other sources of supply, such as from recycling. Instead of buying virgin plastic material, you could buy recycled plastics. Instead of buying virgin paper, you could buy recycled paper. Instead of using fossil fuel in your plant, you could use renewable energy. As for rare earth minerals, there is ongoing research and development to find synthetic substitutes to natural elements. Anyways, the changes that you can make will depend on your operations. There is no one-size-fits-all solution. As an SME, you may find it helpful to rely on proven sources to improve your supply. For instance, if you buy products awarded with third-party verified eco-labels, it ensures that you use the greenest products that fit your needs. For example, the EU eco-label covers more than 30 product groups, including detergents, floor coverings, lubricants, paper products, and more. Therefore, when launching a procurement process to secure your supply, you could include environmental criteria. Let's imagine that you are now a fully resource-efficient SME. You consume as few resources as possible, you design environmental-friendly and easy-to-recycle products. All of this, as we said, is in your control. However, there are still many areas where you will need a little help from your business partners to make a change. By definition, you cannot make the change to a circular economy alone. A circular economy is all about being open to new business opportunities. And there are many ways for you to be part of a broader and cleaner industrial ecosystem. You may wish to turn your neighbors into business partners. This is industrial ecology. Turn products you sell into resources you recover. This is reverse logistics. Turn your business model from for sale to for rent. This is a functional economy. Industrial ecology, or industrial symbiosis, aims to save energy and resources by transforming one company's waste into another's resource. Output becomes input in a different part of the ecosystem. The most famous eco-industrial park in the world is located in Kalundborg, Denmark. Nowadays, it includes 9 private and public enterprises which are linked together with other 30 material exchanges. For instance, fly ash from the power station is sent to a local cement company, which turns it into gypsum boards. Also, water reuse schemes have been developed within Kalundborg, together with many other cooperative solutions. The Eco-Industrial Park of Kalundborg enabled many economic benefits and environmental savings. For example, over 240,000 tons of CO2 emissions are avoided each year, which is equivalent to the emissions of over 32,000 European people. This success is not unique to Denmark and could be reproduced near you. Have a look at other examples of industrial parks in Europe on the ECAP website at the address on the screen. Also, some country-specific initiatives have been set up to connect businesses and shape opportunities. To learn about the National Industrial Symbiosis Program in the UK, follow this address, or this additional address, which provides guidance by the French Ministry of Sustainable Development. Other interesting information and examples can additionally be found at the EU Cluster portal address. Just as life does not stop at your business's door, your business does not stop once your product is sold. You may prefer to not think about the future of your products. You may think it's none of your business. In fact, you could be ignoring a profitable opportunity, since the resources in the products you sell today can be recovered and recycled into resources for products you will sell tomorrow. One option is to create a reverse logistics system on your own, where you take back the products that you sell to your customers. This may be easier to do if you are operating in a business-to-business operation. If, for example, you provide company offices with homemade apple juice, you could take back the empty bottles rather than letting your customer throw them away. You could formalize this process through a contract or systems like deposits. Once you get the empty bottles back, you just wash them and reintegrate them back into the supply chain. This is a simple case, but if your product is more complex, or if your business is too small to set up a reverse logistics circuit on your own, you can pool resources and have a shared organization that collects and recycles on your behalf. The following example from France is a good one. 6 main manufacturers of mobile homes have joined forces to collect, dismantle, and recycle old homes. This reverse logistics system is financed through an environmental contribution of €100 for each new mobile home sold. Now, whether you apply reverse logistics on your own, or if you partner with similar manufacturers, for certain waste flows, you don't even have a choice. Indeed, there is a principle in Europe known as Extended Producer Responsibility, or EPR, according to which you're responsible for the products you place on the market at the end of their life. This is the case for a growing number of products, including packaging, electric and electronic equipment, batteries, etc. Under these requirements, you have to take back the products you sell yourself, or you have to join an organization which takes care of waste collection and recycling. Last but not least, be it mandatory or voluntary, be it on your own or with others, reverse logistics ensures that recovered resources feed loops that facilitate better supply, as was seen in the first part of the video. If you start including reverse logistics in your operations, your old products don't simply become waste, they become raw materials for a new product. You are now at the heart of a circular economy. However revolutionary green you have been so far, you may still be selling a product. With a functional economy, you can go one step further. You don't sell your product, you rent or lease it to your customers. Take a German company, for instance, which provides chlorinated solvents used for high-precision metal surface cleaning. As this industry's sales started to decline in the mid-1980s, the newly founded company got the idea to rent their solvent-filled containers to their customers, instead of selling them. This resulted in the short-term, closed-loop lending of solvent containers in which their customers were able to rent the containers to clean their metal pieces without worrying about waste disposal. The shift to a service-oriented business model made the company a big success story, as it achieved a growth in revenues and a decrease in solvents use. If you sell your products and take them back as waste, as we previously defined as reverse logistics, you become responsible for them even after they have been sold to consumers. If you rent your products, you are going one step further by keeping them as your property. This radically changes the way you design your products. If you continue owning your products throughout its functional and end-of-life phases, you will want them to last as long as possible, and you will design them so they have as long a life as possible. Furthermore, in some cases, long-term rentals and subscriptions can provide a steadier stream of income, making your monthly accounting more constant and easier to manage. The aim of a circular economy is to minimize the net uptake of resources and their associated negative environmental impacts. SMEs have a crucial role to play in achieving a circular economy, and as you can see, there's a lot of work to be done. Fortunately, as the concept of circular economy is rapidly rising on political agendas, you will not be alone in Europe. Just look at what the European Union is already doing for you. In July 2014, the European Commission released a general plan targeting SMEs in a green economy. The overall objective of the Green Action Plan is to enable SMEs to turn environmental challenges into business opportunities. It sets out a list of EU actions supporting SMEs in a green economy, ranging from green entrepreneurship to access to the markets for green SMEs. All in all, it provides a favorable environment for green business across the European Union. You can learn more about the Green Action Plan for SMEs on the European Commission's website by following the address on the screen. You'll also get more information on how the European Commission is addressing their economy. European funding programs do exist. You can have a quick overview of funding opportunities. In contrast to today's larger linear take, make, use, dispose economy, a circular economy represents a great opportunity to transition into a business model that will be more robust and resilient in the years to come.
Yeah, that's all the session is. We have seen what is sustainability through documents and what really the crux of it is. How manufacturing can be sustainable. What are the efforts taken globally? See, we are to how to be in a circular economy or functional economy. How to be a part in sustainable manufacturing. So with that, I close. Now the session is open for questions.
Noel?
Thank you, sir. Now the floor is open to the question and answer session, and I will be moderating the session. I request the participants to please send in their queries over to the everyone option in the chat box, or the participants can also unmute their mics using the reaction option, that is raising hand option in the Zoom platform, to ask their question to the speaker during the question and answer session. Participants, please feel free to unmute your mics and ask your question to the guest speaker, or even you can type in your questions in the chat box. Sir, I have received one question directly. Sir, the question is, how can Indian economy implement the sustainable manufacturing concepts? At the same time, how can we achieve sustainability concepts?
Yeah, understand. See, in Indian context, see, we have already have interaction with the manufacturer. One of the close associates is Hyundai Motors, Bharat Heavy Electricals. See, they go for a global tender. See, when you for a global tender means it has to be all the components used, the process used should be environmental. You have to certificate. And there is a questionnaire, you know, this there are environmental friendly or sustainable one. There is 14,000 series are there. Some standards are there. They have to fulfill the standards. There are people who to audit this, and then they say how product process itself is sustainable and the product is sustainable. So then only we can bid, we can be participate in your trend. So the automatically, as I say, no, we do nothing called Indian economy. It's a global. We compete and we are all free to go global. We be a supplier. Many of the companies are now supplier globally, and then we can assemble electronic components, or we can manufacture gas turbines to Boeing. Whatever it is, no, we have to follow that product. It become is the product sustainable? Is the process sustainable? All these questions. There's a questionnaire you have to fulfill. Then only we can bid. You can participate in the global market. That is a very statutory one. That's why it became a subject. We have a subject on sustainable manufacturing. We have a lot of students doing project on sustainable manufacturing. And maybe this is a forum where we have to teach them so that even their own level, no, whatever level they are in, we are whether take about manufacturing is my domain. So we are doing it. Just I have shared a few of them. It is not only manufacturing, any part, even social life, no, you don't take carry bags. No, you have your own bags. And then try to take containers in buying. No, this non-recyclable politics is polluting the rivers, polluting the water storages, and then it does much harm. And then we are contributing. We have to contribute. That's how the first part of the first lecture is totally sustainable, global sustainability. What is sustainability? How globe to be sustained? And what is the role as a person who are living now, present day? We have to leave the best world to the future. You understand that is the concept we are bringing in. And then manufacturing as a role, and manufacturing is global. So automatically you have to know that nothing called Indian. Indian is also participating in global tenders. We supply. You know, suppose you want to build a bridge, then you have to see the building, no, sustainability. I have few more videos, but I did not show them. Every domain you have, how you can be sustainable. Like manufacturing, you know, how construction becomes sustainable, how pharmaceuticals be sustainable, how chemical industries can be sustainable, how thermal plant can be sustainable. These are aspects are there. Okay, I think I have answered.
Yes, sir. Any other questions, participants? Please feel free to ask.
The participants can also share their. We see chat box is open only. I have posted. No one has posted. See, you have to have a practice. You have to. I think I need to have a feedback. What is your understanding? Maybe the course conductors has to take a feedback. One point is maybe some of you may be new to this. But we have been working on this sustainability for long, and then we have many MTech students and one or two PhD students are doing on sustainability. Yeah, that is focused on industrial sustainability. And as I said, no, there are some of the research scholars can focus on this area, which lot of challenges are there. I told you a lot of challenges are there to be sustainable, because the world has gone as they like. The products are done without any mind on sustainability. So the products are creating, it is helping us. Simultaneously, it is damaging more than helping. It may help you. Suppose I said in India, I will buy electronic goods like maybe electric cars. No, electric cars are not available because of batteries. You know, the batteries has to be excavated, mining, and lot of process goes on, and it pollutes the environment some other place. Maybe the battery in your country, when you buy it, do it okay. Okay, many European countries have shut down the manufacturing because manufacturing process is not user friendly. It pollutes the air. It pollutes. It excavates a lot of minerals. It depletes energy sources. So they don't want. But we have a call that make in India. No, we want to manufacture, but we should be very cautious. We should see how it is. If you have a manufacturing user-friendly, eco-friendly, without depleting our source, if you are manufacturing, well and good. Otherwise, we are emptying our own basket, and our we will be deprived, and we have to starve one day. So please understand this. Wherever possible, you have to communicate this. Is it all right? Any questions?
Sir, are there any government policies related to sustainable manufacturing in India?
No, there are standards for the products. No, this is like 14,000 series. This Bureau of Indian standards, they have for environmental statutes. No, they have put 14,000 series are there. Bureau of Indian standards. There are standards done to make sustainability a product, sustainable process, and so on. It is there. And already, many use of plastic is banned, in our country, in our cities. Maybe in our own place, you could see that. And already we have to see degradable and biodegradable and then non-degradable objects. You have to keep separate. So that has to be. So this e-waste management, recycling, reverse logistics, all the topic of the day they are doing. And we should be. We are. As you say, we are not mindful. At least engineering graduates or engineering discipline, we have to advocate. Consciously, we should do that. Even if we make a product, it should be user-friendly product, environmental-friendly product.
Okay, sir. No more questions have come. I think we'll close down the question and answer session.
Okay.
Thank you very much, sir, for this enlightening session.
Thank you for giving me a chance to. I actually revised my content so that I will improve the content whenever the presentation is done. But I expected interaction. You should motivate people to interact. And then I could not see the interaction. Whether they are there in the point or when they logged in and left. You have to check, put some questions, no? These online classes are always threatening. You have to, normally I will call them, but of course, they are your participants. You have to keep them busy or tagged. They have to follow, otherwise no use it is. They just check on and go. It is not getting a certificate. What is that getting a certificate? Get some knowledge, right?
Okay, sir. We will try to look into that.
Participants to accept one or two. Others, you have to interact. Hope if it is useful, it's okay.
Sir, thank you very much for the informative presentation on sustainability and sustainable manufacturing. Thank you for spending your valuable time with us on this platform. Thank you very much.
Thank you, Raju. Convey my regards to your principal, your HOD,
Sure, sir.
Team. Okay. Is this the first lecture, right?
Yes, sir. This is the first session. Session 1, first lesson.
Can see other sessions you make it successful in 3 days, is it?
Yes, sir.
Okay. Do well. All the best. Bye.
Thank you. I now request Dr. Knut Sherwin, Assistant Professor in the Department of Mechanical Engineering, SJAC, to give the vote of thanks.
Good afternoon, sir. I will. First of all, I would like to thank Professor Kumanan NIT Trichy for his session on sustainable manufacturing. It was a very informative session, and you delivered an importance of sustainable development in manufacturing. I would also like to thank our principal, Dr. Rio D'Souza, for his constant encouragement in organizing the FDPs with a vision to motivate research among the faculty members. I would also like to thank the management of St. Joseph Engineering College for their support in organizing this FDP, director as well as assistant director. I would like to thank our HOD, Dr. Srirangapat, for his guidance and help in organizing this FDP. I would also like to thank the conveners of the program, Dr. Raju K, Professor, Department of Mechanical Engineering, and Mr. Noel Deepak Shetty for their help in organizing this FDP. I would also like to thank Noel Deepak Shetty for being the MC of the program. My thanks are due to Dr. Binu KG, Professor in the Department of Mechanical Engineering, for setting up the Zoom platform for this FDP. My sincere thanks to all the teaching and non-teaching staff members who have directly or indirectly helped in organizing this talk. Thank you, one and all. Yeah, the second session for the FDP will be at 2:30 p.m. I request all the participants to please log in by 2:15 p.m.
I request the participants to please fill the feedback form as links are being posted in the chat box. We look forward to many more interactions with you in the coming sessions. We thank you for your participation. We will start the afternoon session 2 sharply at 2:15 p.m. Thank you. This is Noel Shiri signing off.